Sometimes we're not able to use a simple triangle to calculate function values or trigonometric function values. So instead, we have to use a calculator. So today we just want to look at a couple of applications on a calculator, a couple of things that you're able to do with the calculator. So let's get started. There are two different modes that your calculator can be in. The first mode is considered degree mode, often just DEG, while the second mode is called radian mode, RAD. Now these are actually just two different units of measurements for angles. And we're going to be learning about radian measurement coming up here soon. But for now, we're only dealing with degree measurements. And one good check to make sure, just at the beginning of every time you use your calculator, just to make sure you're in the right mode, let's try to find out what sine of 90 degrees is. Well, 90 degrees, remember, is going to be this angle over here. So if you were to pick some particular value on the 90-degree angle, remember that sine of 90 degrees is just the y value over the r value. Notice that the y value is, well, whatever we want it to be. So let's just make it, I don't know, 2 or 23, or to make it nice and easy, 1. And so we could see that the distance from the origin is also 1. So sine of 90 degrees is 1 over 1, or just 1. So we should know that sine of 90 degrees is 1. And so if we were to use a calculator, it should turn out to be the same value. So I'm going to use the calculator that's on our computer here. And in order to make sure that you have the right computer, you need to make sure, first of all, that you have the buttons of sine, cosine, and tangent. And it's important to also recognize that oftentimes it's just the button, or it's something that shows up right above the button for sine. It'll say sine with a little, it looks like an exponent of -1. But that's just the inverse notation, right? It's inverse function notation for sine. So it should have a sine inverse, cosine inverse, and tangent inverse button as well. So let's go ahead and find sine of 90 degrees. On this calculator, you have to type in the angle first, and then you hit the sine button. On your calculator, it might be the exact opposite. You might hit sine and then 90. But notice that when it asks for, or when you calculate sine of 90 degrees, it shows the answer as 1. That means we're in the right mode. We could also see we're in the right mode because it says DEG. Sometimes you'll see that on the bottom of your screen. Now I'm going to change this to radian mode and just show you what would happen if I try this again. If I type in 90 and sine, now it's not 1 anymore. It's 0.893996. And so notice that this is not the right mode, so we need to make sure that we go up and change it to the correct mode before beginning. Everybody's calculator is a little bit different. Some of you may have a button on your calculator that involves degrees, minutes, and seconds. Sometimes that button would say something like DMS, which allows you to type or hit that button and put in certain degrees, minutes, and seconds. Most calculators don't have that feature. So if I want to calculate what sine of 49 degrees and 12 minutes is, the first thing I have to do is convert it into a decimal. So remember, the minutes are 60ths of a degree. So we could convert this into 49 degrees with an extra 12 60ths of a degree. Now let's go to our calculator and find out what 12 60ths is. So 12 divided by 60 gives me a decimal value of 0.2. So now what I can do is I could type in 49.2. I know I'm in degrees because my calculator says so up here. And so if I now calculate sine of 49.2 degrees, this is my answer. Now we're in general going to be rounding to approximately 3 to 4 decimal spaces. That's going to be sufficient for most of the problems that you deal with, especially the word problems or applications. So therefore we could see that it would be 0.756995. So 756,995. Okay, And if I wanted to round that obviously to the nearest thousandth, then I could, to the nearest thousandth, I could say that this is approximately equal to 0.757 or so. Okay, so that's how to deal if you have degrees, minutes, and seconds. But I'd like to do another one. Let's say that we had something like cotangent of 51.4283 degrees. Well, you might think, well, let's just go ahead and find the cotangent button. The problem is no calculator has a cotangent button. Calculators will only have sine, cosine, and tangent. So there's a couple of ways to do this. The easiest way that I'll show you is by recognizing from an identity, sometimes you have to do a little bit of work first, that this is the same thing as 1 over tangent of that quantity. So I really just need to find what tangent of that angle is by using my reciprocal identity. And once I find tangent of that angle, I can take the reciprocal. So if I punch in 51.4283 and find tangent, now I've got a couple of options, okay? I could either go back and write out this value of 1.253948, 1.253948, and recognize that that's the denominator of my answer. And now I would have to take 1 and divide by that quantity. There's an easier way to do that though. If you click on your calculator, there's actually a button that looks like 1 over x. So what that'll do now is it'll take whatever answer is showing up on your screen, and if you click 1 over x, that's going to give you the reciprocal of that value. So now I can see that it says 1 over tangent of 51.4233, and that's how we can calculate cotangent. So cotangent is approximately 0.7975. 0.7975, and there we go. So now we can calculate degrees, minutes, and seconds. We can calculate cotangent, cosecant, and secant values. But it turns out that there's one other really helpful tool for a calculator, and that's going backwards to find an angle if you know what the corresponding ratio is. For this last example, now notice that we're told the value of secant of theta is 1.054589. And we're trying to find what angles would give that particular value. Now keep in mind, there's no secant button on my calculator, but there is a cosine button. So let's think about what that would imply. If secant of theta is that value, then that would imply that cosine of theta is 1 over this value. So now that would show that we're trying to find out the angles where cosine of theta is equal to this number. So we get 1 divided by 1.0545829. Okay, we get approximately 0.948242. $0.948242. So approximately 0.948. So how do we determine where that's going to be? So the general idea about this is that we're going to be using these buttons referred to as cosine inverse, sine inverse, tangent inverse. And those buttons are used in order to find a particular angle if you're given the ratio. So if cosine of theta is equal to 0.948242, we can rewrite this to solve for theta if we use the inverse function, just like in algebra. So we take cosine inverse of 0.948242. Great, so now that's going to give us what the angle is. Let's go ahead and try that. So we already have our value up here. You could keep it in the screen. And now if I just come down here and press cosine inverse, that should take me back to whatever the degree measurement actually is. So cosine inverse, sine inverse, all the inverse trigonometric functions will give me an angle. So 18.515. So theta equals 18.515 degrees. But I'd like to take a look at the diagram to see what this really means. So this is basically saying that if I were to take a look at the angle of 18 degrees, okay, 18 degrees is a really shallow angle. So it's going to be somewhere, there we go, 18 degrees is somewhere around here. Okay, a pretty shallow angle. So we're being told that the cosine value is going to be the cosine of this angle is going to be this value, 0.94824. But I'd like you to keep in mind that this value here is positive. And so when I'm looking at all of the angles between 0 and 360 degrees, right? Here's 180 would be a half a rotation, all the way back around to 360 degrees. Turns out that that's not the only angle that's going to give this value. This angle is 18 degrees, 18.515 degrees, but that's not the only place where cosine is positive. This is where ASTC comes into play. Remember, in the first quadrant, all of the ratios are positive. In the second quadrant, only sine is positive, but cosine is negative. So I know that my angle can't be in the second quadrant because that's a positive ratio. So now I go to the third quadrant. Notice that only tangent is positive. Sine and cosine are negative. So I know my angle can't be in the third quadrant because of the fact that this quantity is positive. But take a look at this fourth quadrant now and realize that there is some location that's going to give me the exact same ratio. And that's because if you take a look at this triangle right here, there is another triangle in the fourth quadrant that's going to give me the exact same triangle. Look at this other triangle in the fourth quadrant. It also has the same exact reference triangle, which means it also has the exact same reference angle. So although your calculator only gave you one answer, the calculator is only going to give you one answer every time you try to find an angle. And it's only going to give you the answer in the first quadrant. But we need to find the other angle between 0 and 360 that has a reference angle of 18.515 degrees. So we just need to find out that if this is the angle 18.515, then we need to find out what is this angle that will have the exact same cosine value. Okay, and so we just need to find out what is the coterminal angle, or sorry, the reference angle to this. So theta prime would be 360 degrees minus 18.515 degrees. So if we take 360 minus 18.515, that gives me 341.485 degrees. $341.485, and that is our second angle where cosine of theta is equal to, or where secant of theta rather, is equal to 1.0545829. So notice that for any value we're trying to find, if we're for any angles, if we're ever trying to find angles, there will always be two quadrants or two answers per ratio. And so our job is to find both.